Hi, my name is Jeff, and today we're going to learn about scientific notation. Now, the reason I made this video is because I teach scientific notation just a little bit differently than you may have heard it in the past. In high school, when I was learning it, it was confusing. I knew the right to left and all that with the negative, positive, exponent. It was really confusing to me. So I kind of developed a method that to me makes more sense and it's a little easier to understand. And it's also it's a check at the end of an answer you give. You can do this kind of to apply this method to your answer to see if it makes sense or not. So without further ado, let's get started. So scientific notation, what exactly is it used for? It's for writing very, 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 very large numbers, number of bacteria in, say, a drop of seawater, and very, 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 very small numbers, and include a lot of zeros. It might be easier to express those numbers in scientific notation. In scientific notation, we have the first number needs to be at least 1, but less than 10. Okay? And then we're going to times it by base 10. And up here, we have a little exponent. I'm just going to put a little e up here for exponent. And that exponent, it tells us the number of spaces that we need to move our decimal point. So our front number needs to be at least 1, but less than 10. So I'm going to put up 3 numbers here. The only number that we can use of these is this number. And the reason is this number is less than 10. This number isn't 1 yet. This number is greater than 10. And this exponent, I'm just going to go ahead and write an exponent of 4. Okay, as our exponent. So what that tells us, and if I were to rewrite this, so this is scientific notation. And I'm going to show you what we do with it at this point. We're going to convert this to standard notation, and all standard notation is numbers that you're typically familiar with. So we're going to turn this into just a regular number. And the way we do that is, the way I do that, is I write this number again, 9. I'm just going to put a really tiny dot there for the decimal, and then 0.9763. Okay? This 4 tells us how many spaces to move that decimal. So we're going to move it 4 spaces. Now the question is, do I move it this way or do I move it this way? Now, the way you've been taught, if you were taught this in high school, the way it's taught is because this is a positive exponent, we're going to move it in the positive direction. Okay? So let's erase this line. We're going to move it to the right. And what that's going to do is it's going to make our number larger, right? Right now it's 9.97. I move it 1 time, it's now 99.763. If I move it again, it's now 997.63. If I move it again, it's 9,976. And if I move it, this is 1, 2, 3, 4. And that's the new place for the decimal, because it told us to move it 4 places. So this scientific notation right here is equivalent or represents 99,763. And you're saying, well, why not just write 99,763 and forget about this? Well, you could, because this isn't a really large number in scientific terms. This is a large number to us. It'd be certainly a large number in my bank account, but it's not a large number in scientific terms. Some scientific numbers might have as many as 50 spaces after a decimal. So this is a relatively small number in scientific terms, but these are equivalent. And the decimal, we're not going to write it. It goes right there. what makes it confusing is, let's say 0.0365. I want you to convert this to scientific notation. Now this is just a small number. Convert it to scientific notation. So where would this decimal need to fall? Would it fall here? No, because that would be 0.3, which is less than 1. Would it fall here? No, that would be 36.5. That's greater. So where we're going to put it is right there. Okay? So I'm going to write it down right here, 3, 6, 5. And I know my number is going to look like this. So my lead number is 3.65, and that is a number that is at least 1 and less than 10. And then I'm just going to go times 10. And then how many spaces did we move that decimal? Well, we moved it 1, 2. Okay? Now here's where it gets confusing. Which direction did I move the decimal? Moved it to the right. So should this exponent be positive or negative? Now if you're thinking, oh, it should be positive, you moved it to the right, you would be wrong. And that's where it gets confusing. What is the number that we started with? Well, we started with 0.365. Is it greater or less than 1? Well, it's less than 1. If the number's less than 1, it will always be a negative exponent. And I'll show you why that is. Because this is the number that we started with, it's less than 1. If we were to convert this number back into scientific notation, all we would do is write the 3, the 6, and the 5. Okay? Our decimal's currently here. How many places do we move the decimal? 2. Well, if I move it to the right, doesn't that give me 365? It doesn't give me this. So I have to move it this way. 1, 2. And then I would put a little placeholder there. And now this number matches this number. So if it's a negative exponent, the number we started with in standard notation is actually less than 1. If this were a positive exponent, we know that our number that's represented here by scientific notation is a number that is larger than 1. So again, the first number needs to be at least 1, but less than 10, times 10 with an exponent. And all the exponent does is tells us how many spaces to move the decimal point. So let's do some practice. So it's saying which answer represents the following number in scientific notation. Well, let's look at it. First of all, is this number larger or smaller? Greater or less than 1? Well, it's less than 1. So we could rule A out right away because this has a positive exponent. So it's going to be one of these numbers. The question is, where does the decimal need to be? What is our front number going to be? And the way we do that is we can simply cover up everything here until we get to a first number. 4 is our first number going to the right. So we know our first number in this scientific notation is going to be 4.207. And we know that because if we stopped before the 4, we'd have less than 1 in front here. It'd be 0.4, and we can't have that. It's got to be at least 1. And if we did after the 4, it would be 42, and that's greater than 10. So we know where our decimal needs to be. And we use the numbers, and we put times, and then we put 10. And now we just have to figure out our exponent. How many places did we move the decimal? We started here. We moved it 1, 2, 3, 4. So we moved it 4 spaces. And without even looking at the possible answers here, I know that this should be a negative exponent because this number is less than 1. And so when I look at here, there it is, boom, D. This one says our moon is approximately 0.389 times 10 to the 5th power miles from Earth. Write this distance in standard notation. So now what we're doing is we're going to convert this to numbers that we're used to. And it should be pretty easy. We just write this number. I'm going to use a different color. Let's use green. So we just write 2, 3, 8, 9, and it's got 5. I'm going to put a few zeros here. Okay, just for placeholders. Okay. Now, we start here, and I have a positive exponent. So is my number going to, the number that's being represented, is it greater or less than 1? It's greater than 1 because it's a positive exponent. That's how I know. So if it's greater than 1, I need to move my decimal point this way, because that's what's going to make my number greater than 1. Right now, it's 2.3890000, right? To make it larger, I got to move this decimal point this way. 1, 2, 3, 4, 5. And if I erase the movement here, that should give me a total, and these don't matter now because it's after the decimal. If I gave you $1, if I gave you $1 and 0.00000000 cents, how much am I giving you? I'm just giving you $1. The zeros after the decimal don't change the value any more than the zeros in front of the dollar. So you can always pull a trick on somebody and say, you know what? I'm going to write you a check. It's going to have a 1 and it's going to have 9 zeros on it. You're like, oh, sweet. And you give it to them like this and it's $1. All right. I have digressed. So this number here is really, start from the decimal, go 3, make a comma. So this is 238,900 miles. That's how far our moon is approximately from Earth. 238,900 miles. Write the following product in scientific notation. Okay, well, isn't it in scientific notation already? It's not. So why isn't it already in scientific notation? Well, there's no 10 with the exponent, right? So, but we can do multiplication. If you multiply 1, 2, 3, 4. But let's go over here for a minute. If you have $5 and I say, I want you to multiply that by 1, how much would you have? You would have $5, right? If I said, hey, I want you to multiply $5 times 10, how much would you have then? You just add a 0 to it. You'd have 50. And if I said, multiply that, if I can make a dollar sign, multiply that by 100, and you would end up with $500. So what did we actually do to this number? Well, the decimal was here before, right? And there's a 0 here. Remember, the zeros after the decimal don't really matter. But when you multiplied it by 1, it didn't move anything. If you multiply it by 10, you move that decimal from here 1 space this way. It gave you 50. When you did 100, you basically moved it 2 spaces. So when you multiply by 1,000, you're going to move this decimal here 3 spaces. 1, 2, 3. There's our new decimal. And we're going to use zeros as placeholders. So this number represented is 123,000 400. So this number represents 123,400, just on basic multiplication. To convert it to scientific notation, like it wants us to, where does the decimal need to be? Right now it's here. We need it to be here. Because if it was here, it'd be less than 1. It'd be 0.1234. If it were here, it would be 12.34. But we want the decimal to go here. So let's write our number. It's going to be 1.234, and that certainly fits our criteria, times 10. And our exponent, well, how many places did we move that decimal? Went from here, 1, 2, 3, 4, 5. Now, does the exponent need to be positive or negative? It's pretty safe to say that this number represented here, 123,400, is greater than 1, so it's going to stay positive exponent. And that is our answer. Okay, so let's do one more. A shipment of Slinky toys weighs 7 tons. Based on information in the table below, which of the following expressions could be used to express the weight in metric tons? So here's a ton. Here's, we all know a ton is 2,000 pounds. A metric equivalent is 0.907 metric tons. So let's do the process of elimination here. So these are scientific notation, okay? This part in the front, you're just multiplying it. So by saying 7 metric tons, you're just saying, let's pick a color here. We're saying 7, and then we're putting in a scientific notation down here, which would be times 10 to a certain power, okay? We don't know what that is yet. And our number in front is going to be between, well, it's going to be at least 1, and it's going to be less than 10. So let's rule out some of these. Well, A, that doesn't look like scientific notation. This is less than 1. So A's out. C is out. And that leaves us with B, D, and E as our possible choices. So let's look at this number. We have 0.907. First thing I want to look at is this greater than or less than 1? It's less than 1. So I know my exponent is going to be negative. Now let's look at it. What does this number need to be in the front here? Where do I need to put this decimal point? Am I going to put it here or here or here? Well, it's going to go right here. Okay? And to put it there, I'm only going to move it one time. So I know that this number up here is a negative 1. And I know my number that needs to be up here is 9.07. So that would be the correct answer. So we know A is wrong already. B is wrong because that's moving at 2 spaces. C is wrong because it's not scientific notation. D is wrong because it has a positive exponent. That means my answer is greater than 1, and this certainly is not greater than 1. So E is the correct answer. So I hope this has been helpful for you. Thank you, and have a pleasant day.